Good day everyone, especially to our grade 9 learners. For today, we are going to discuss graphing quadratic functions. So, how do we graph a quadratic function? The first thing that we are going to discuss is the opening of the graph of a quadratic function. Remember that the graph of a quadratic function is a parabola that opens either upward or downward. So if a is greater than 0, meaning it is positive, the parabola opens upward. But if the value of a is less than 0, meaning negative, the parabola opens downward. Let's have an example. In the quadratic function y equals x squared plus 6x plus 9, the value of a is equal to 1. It is greater than 0, that means that the parabola opens upward. Another example. If y is equal to negative x squared plus 6x minus 4, notice that the value of a is negative 1. Since a is less than 0, then the graph of the quadratic function negative x squared plus 6x minus 4 opens downward. Next is the axis of symmetry. Every graph of a quadratic function is a parabola that is symmetric about a vertical line through its vertex called the axis of symmetry. In the quadratic function x squared minus 2x minus 3, notice that this is the graph of the quadratic function. There is a vertically dotted line here that divides the parabola into two portions. These two portions are symmetric. And it is symmetric when x is equal to 1. Therefore, the axis of symmetry is x equals 1. Notice also that the parabola opens upward since the value of a is greater than 0. Let's have another example. F of x equals negative 2x squared minus 8x minus 6. Notice that in this quadratic function, this is the vertically dotted line. This vertically dotted line, when x is equal to negative 2, is our axis of symmetry. Notice also that our graph opens downward because a is less than 0. There also exists a relationship between the values of a and b in the quadratic function. That means, to find the axis of symmetry given the quadratic function, we can also use the formula x equals negative b over 2a. So let us try to use this in the function negative 2x squared minus 8x minus 6. The value of b is negative 8. The value of a is negative 2. When you substitute, you will have negative of negative 8 all over 2 times negative 2. That means this is equal to the negative of negative 8 over 2 times negative 2 is negative 4. But what is negative 8 over negative 4? That is now positive 2. So negative of 2 is equal to negative 2. That means that the axis of symmetry given the formula is also the same. X is equal to negative 2. Let us have another example. In the quadratic function y equals x squared plus 2x minus 3, the value of a is equal to 1 and b is equal to 2. Let us now use the formula to find the axis of symmetry. X equals negative b over 2a. Let us substitute the values of a, which is 1, and b equals 2. So x equals negative of b, which is 2, all over 2 times a, which is 1. So the answer would be negative of 2 over 2, which is equal to negative 1. That means the axis of symmetry is x equals negative 1. Let us check that in the graph of the quadratic function. This is the graph of the function y equals x squared plus 2x minus 3. Notice that it is opening upwards since the value of a is greater than 0. This is the vertically dotted line, and this is the axis of symmetry when x equals negative 1. Next in graphing quadratic function is the vertex. The vertex is the point where the line of symmetry crosses the parabola. In this graph, notice that this is our axis of symmetry when x equals 1. This point here, where the line of symmetry crosses the parabola, is what we called the vertex, and this vertex is at 1, -4. In another example, this is now our axis of symmetry. The axis of symmetry is x equals -2. This is now the vertex, wherein this is the point where the line of symmetry crosses the parabola. And this is at -2, -2. This time, how do we determine the vertex if the graph of the quadratic function is not given? For example, we have here y equals x squared minus 2x minus 3. As we have discussed before, there are two ways on how we can do that. We just need to change this into the vertex form. The first one is through completing the square, and the other one is using the formula to find h and k. Let us first use the completing the square. If you remember, we just need to group together the terms containing x. Next one is to factor a. But this time, since a is equal to 1, all we need to do is to complete the expression in the parentheses to make it a perfect square trinomial. That means we need to divide the middle term, -2, by 2. And then you need to square it. -2 over 2 is -1. -1 squared is 1. That means we need to add 1 and subtract the same value from the constant term. That means that the vertex form is now equal to y equals the quantity x minus 1 squared minus 4. In this vertex form, h and k here are the vertex, and the vertex is at 1, -4. Now, let us use the second method in finding the vertex, and that is through the use of a formula. Remember, the formula in finding the vertex is h equals -b over 2a and k equals 4ac minus b squared over 4a. In this quadratic function, the value of a is 1, b is -2, and c is -3. Now, let us find the value of h. H is negative of -2 over 2 times 1. Negative of -2 is 2. 2 times 1 is 2. 2 over 2 is equal to 1. Therefore, h is equal to 1. Now, let us have k. When we substitute the values of a, b, and c, we'll have 4 times 1 times -3 minus -2 squared all over 4 times 1. Simplify, we have -12 minus 4 all over 4. -12 minus 4 is -16 over 4, which will give you -4. That means the value of k is -4, and the vertex now is at 1, -4. Now, let us identify how do we find the x and the y-intercepts of a quadratic function. The x-intercepts are determined by setting y equals 0 and then solving for x. The quadratic function y equals ax squared plus bx plus c may have two distinct x-intercepts if b squared minus 4ac is greater than 0. There is only one x-intercept if b squared minus 4ac equals 0, and there will be no x-intercept if b squared minus 4ac is less than 0. Now, how about the y-intercept? The y-intercept is determined by setting x equals 0 and then solving for y. Now, let us have an example. Suppose I have y equals x squared minus 2x minus 3. Let us first find the x-intercept. Remember, we have to let y be equal to 0, then solve for x. So if y is equal to 0, we'll have x squared minus 2x minus 3, which is a quadratic equation. So how are we going to solve this? We can apply factoring. We look for numbers that when you multiply is negative 3, but when you add is negative 2. The factors are x minus 3 times x plus 1. Then, equate it to 0 and solve. We'll have x equals 3 and x is negative 1. Notice that there are two x-intercepts. These x-intercepts are the points on the parabola that crosses the x-axis when y is equal to 0. And that is negative 1, 0, 3, 0. That means the x-intercepts are negative 1 and 3. Now let us find the y-intercept. Remember, to find the y-intercept, all we have to do is to let x be equal to 0, then solve for y. If x is equal to 0, you'll have 0 squared minus 2 times 0 minus 3. That means y is equal to 0 minus 3, or y is equal to negative 3. So, given the graph, this y-intercept is the point on the parabola that crosses the y-axis where x equals 0, and that is this point, and that is at 0, negative 3. That means the y-intercept is at negative 3. Next is to find the domain and the range. In this example, the graph opens downward. The vertex is at negative 1, 4. The domain is the set of all possible values of x. Well, to identify the range, we need to find the value of k. If the graph opens upward, then the range is y is greater than or equal to k. But if the graph opens downward, the range will be y is less than or equal to k. In this example, the domain is the set of all possible values of x. That means the domain are all real numbers. Since the graph opens downward, we need to find the value of k, which is 4. Therefore, the range is y is less than or equal to 4. Let us have another example. In this graph, the vertex is at 4, negative 4. The domain is the set of all real numbers. Since the graph opens upward, that means the range would be y is greater than or equal to negative 4. Another example. The vertex is at 0, 6. Therefore, the domain is the set of all real numbers. The graph opens downward, that means the range would be y is less than or equal to 6. Now, let us graph the quadratic function x squared plus 4x minus 5 using the techniques that we have learned. So first, a is equal to 1, b is 4, and c is negative 5. Notice that a is greater than 0. Therefore, the graph opens upward. The axis of symmetry is given as x equals negative b over 2a. When you substitute, the answer would be x equals negative 4 over 2 times 1, and that is x equals negative 4 over 2. That means the axis of symmetry is x equals negative 2. Next is to find the vertex of the quadratic function. Again, the vertex can be found using the formula h equals negative b over 2a and k equals 4ac minus b squared over 4a. When you substitute, h is equal to negative 4 over 2 times 1 equals negative 4 over 2, and therefore h is equal to negative 2. Then, to find k, you just need to substitute to the formula. You will have 4 times 1 times negative 5 minus 4 squared all over 4 times 1. That means the value of k is equal to negative 20 minus 16 all over 4. That is equal to negative 36 over 4, and therefore k is equal to negative 9. That means the vertex of this quadratic function is at negative 2, negative 9. Next is to identify the x-intercepts. To find the x-intercepts, we simply let y be equal to 0, then solve for x. That means you will have 0 equals x squared plus 4x minus 5, which is a quadratic equation. Then, we need to factor. The factors are x minus 1 times x plus 5. Equate to 0 and solve. We are going to have x equals 1 and x equals negative 5. That means the x-intercepts of the quadratic function are negative 5 and 3. Next is to find the y-intercept. To find the y-intercept, we let x be equal to 0, then solve for y. Then, if x is 0, you'll have y equals 0 squared plus 4 times 0 minus 5. Y equals 0 plus 0 minus 5, and therefore y equals negative 5. That means that the y-intercept is negative 5. Again, given the function x squared plus 4x minus 5, the graph opens upward. The vertex is at negative 2, negative 9. The axis of symmetry is at x equals negative 2. The x-intercepts are negative 5 and 1. The y-intercept is negative 5. Next is the domain and the range. The domain is the set of all real numbers. And since the graph opens upward, the range would be y is greater than or equal to negative 9.